Welcome to the introductory tutorial to the microsimulation structure that is the focus of this website. We refer to this structure predominantly by the anagrams Linda and SIDD. The tutorial will begin by defining exactly what SIDD and Linda are. We'll then go over some details of the modeling approach before going into some detail concerning what the model is actually good for. The idea is that by the end of the tutorial, you should have a good idea about whether the modeling approach is likely to be fit for your own research interests. So what are SIDD and Linda? Well, SIDD stands for the Simulator of Individual Dynamic Decisions. Now, this is a framework for structural dynamic microsimulation modeling. Working backwards through this fairly lengthy description, SIDD is a model in the sense that it provides a stylized analytical description of reality. It's a microsimulation in the sense that it projects the circumstances of individual adults. Macro simulations, by contrast, simulate macro aggregates. Dynamic, the model or the framework is dynamic in the sense that each adult is projected through time, and it's structural in the sense that labor and savings decisions are based on something called the life cycle framework. For those of you who are familiar with these things, the life cycle decision problem is based on dynamic programming methods. Finally, SIDD is a framework in the sense that it is designed to facilitate adaptation to alternative contexts. Now, Linda, in contrast, is an anagram that stands for Lifetime Income Distributional Analysis Model. Linda is the UK parameterization of the SIDD framework. SIDD has also been parameterized for other countries, including Ireland and Italy. Now, the model is designed to generate panel data for a simulated population. It takes in data observed at a point in time for a reference population cross-section, which describes all of the characteristics that are taken into consideration for each adult in the reference cross-section. And it projects forward and backward through time those adults. Now, the backward projections are necessary to build up a picture of lifetime circumstances, and when the model comes to project the population forward through time, it is designed to capture the evolving population cross-section. And what this means is that the model takes into account in forward projections international migratory flows, the maturation of children into the model, and the death of adults out of the simulated population. Now, it's important that the model be able to capture the evolving population cross-section in order to consider the implications for a wide range of nationally representative statistics, including measures of relative poverty and the evolving government budget. A big step for us in 2016 has been to make the model freely available for download from the internet at this website. Now, the characteristics that are included in the model and which the model generates for each adult through time have been carefully selected to include those characteristics which we believe are most important in determining responses and effects of alternative government policies. These characteristics include a range of demographics, such as year of birth, age, relationship status, number of children, and age of children, fertility, and so on. Education and education status, student status and education level, health status and the timing of mortality, employment and employment income, investment and investment income. And the vast majority of these characteristics can also all be simulated in a way that is designed to capture the uncertainty associated with their intertemporal development. To understand this somewhat technical point, you should note that although you may know or you will know your relationship status today with some certainty, you can only know your relationship status into the future with some uncertainty. And the model is designed to take that kind of risk fully into consideration. Now, the characteristics in this slide, which are indicated by asterisks, year of birth, age, basic state pension, and retirement, the timing of retirement, must be simulated in a non-stochastic or deterministic fashion, and all other characteristics can be simulated with some uncertainty. Now, the model has been designed for use by non-specialists, and really what we have in mind here are government analysts. The model parameters are altered through Excel, and an Excel front end is provided for the UK variant Linda. Computations are conducted using a standalone executable, which is programmed in Fortran, the source code of which can also be obtained via this website. Outputs of the model include detailed panel data for each simulated adult in the population, which are output in a form that can be imported into most alternative statistical packages for secondary analysis. A selected set of summary statistics can also be reported using the model via Excel files. The development of this model has been supported by a wide array of funders, including UK government, HM Treasury, Revenue and Customs, Department for Work and Pensions, a number of academic organisations, including the UK Economic and Social Research Council and the Australian Research Council, and trusts such as the Leverhulme Trust and the Joseph Rowntree Foundation. Now, normally I would jump into a few explicit examples of how the model works and the kind of results that we have reported in the existing literature. However, it's important to bear in mind one of the fundamental questions that often crop up whenever we talk about this model with third parties is what is it good for? And to make clear that even specialists really can be somewhat confused about this point, there was an article in January's Financial Times entitled "The Bank of England's Haldane Admits Crisis in Economic Forecasts." In that article, Mr. Haldane is quoted as saying that it's a fair cop to say that the profession is to some degree in crisis. His points really are that the problems inherent in placing too much reliance on large models of the economy, which assume people always behave rationally, and that he has a preference to move away from narrow and fragile models to a broader analysis which encompasses insights from other disciplines. Now, Mr. Haldane's comments refer explicitly, presumably, to the models that the Bank of England maintains in order to generate its forecasts. But the same sort of points could be leveled to the kind of modeling that is conducted associated with this website. The model itself assumes that people always behave rationally when it comes to simulate savings and employment decisions. It's a complex model, which could arguably say it is reasonable to say is both narrow and fragile in some important respects. So what is it good for in context of the points that are leveled here? Well, it's important to bear in mind right from the outset that this model is not an appropriate tool for forecasting the future state of the economy. Now, that's somewhat confusing because the model will generate nationally representative statistics out to any time horizon you like. It will, for example, generate numbers for gross domestic product for 2020, 2030, 2050, if you like. And there is a tendency for people to interpret these projections as forecasts for the future state of the economy. Now, unfortunately, that is just not a practical interpretation or a way to use the model in its current format. And indeed, it was never really reasonable to assume that to be the case, even before the financial crisis, which has led a lot of people within who are actively involved with developing these kinds of models to express some confusion when this sort of criticism is leveled at us. The idea that, the financial economics fundamentally missed the global financial crisis. If you miss something so large and important in your forecasting, how can you say that your forecasting tools are of any use whatsoever? Now, the reason that the model that is on this website is not an appropriate tool for forecasting the future state of the economy is that it is highly stylized. It emits all sorts of complexity that is likely to determine the economy's future trajectory, and it therefore cannot comment on the bearing that this sort of complexity might have going forward. It doesn't include the US housing market and the interaction with the US housing market with the financial system and the way that the global economy is integrated so that it might affect other countries like the UK. It therefore is simply incapable of providing a forecast of the likelihood that the US housing market will bear upon the UK, and so it had no chance really of forecasting the 2007 global financial crisis. It also doesn't include all sorts of other forms of complexity, such as the fragility of the European Union, Brexit, the impact that leaving the Union will have. It doesn't include war, famine, health scares, global health scares. It doesn't include global warming and weather change. It doesn't include all sorts of things. And so it's simply not a suitable tool for forecasting the future state of the economy. Now, bearing that in mind, there are two key questions that can be raised. First of all, can the stylizations that I've just been referring to now be relaxed to obtain a tool that is suitable for forecasting the future state of the economy? And secondly, what practical uses can the existing version of the model be put to? On the first of these questions, I believe it's reasonable to suppose that it's simply impractical to relax the stylizations sufficiently to obtain a structure that it provides a suitable basis for forecasting the future state of the economy. The reason for that is that at the heart of this model is, as I noted earlier, this life cycle framework. Now, the life cycle framework is designed to convert incentives on the one hand into employment and savings decisions on the other. The way that it does that translation is to look for decisions which optimize expected lifetime utility. And that process is extremely numerically burdensome in most realistic contexts. Now, in context of the existing computing technology, the numerical burden can only be made practical by introducing the kind of stylizations that I've been referring to here. It's important, I suppose, to make clear exactly why this life cycle framework is important. Effectively, as I noted just a moment ago, this life cycle framework acts as a simple translation from incentives into decisions. Now, you might come up with alternative approaches for conducting this translation, but this is the approach that the economics field has identified as the most sensible to adopt. Now, but the fundamental motivator here is this idea that incentives are important determinants of decisions. If you buy that idea, if you are willing to accept that proposition, then actually the life cycle framework doesn't imply much at all. There has been a great deal of criticism leveled at the approach due to the conspicuous disconnect that the approach has between, what people actually do in practice and this complex numerical optimization that is assumed by the approach. And secondly, that the implications of the framework are out of sync with what we observe in practice. On the first of these issues, it's important to note that although the translator may not be specified in the same way that people actually undertake the translation of incentives into decisions themselves, that's not really the point. The whole point of the life cycle framework is to obtain a feasible approach for conducting that translation. Now, you might not agree with the approach, but if you spend a little while thinking about feasible alternatives to this approach, I think that, certainly when I have thought about this for a great deal of time, I have struggled to come up with an alternative that really competes. Now, bearing that in mind, if you are willing to accept the approach taken for the translation, then actually the life cycle framework doesn't really have any testable implications at all. So this second, key criticism of the framework, that it is out of sync with what we observe in practice, actually doesn't actually make much sense. It's effectively criticizing the formulations that have been implemented in the past, but it is possible to implement all sorts of weird and wacky formulations, effectively alternative assumptions concerning the preference relation, that will deliver all sorts of weird and wonderful behavioral anomalies. The life cycle framework in existing literature, for example, is capable of capturing things like habit formation, intertemporal inconsistency of decision making, procrastination, loss bias, and so on. It's simply a matter of reformulating your preference relation accordingly. So that's a key point to bear in mind. Now, the key reason that this life cycle framework is embedded within this approach, as I say, is as a translator from incentives to decisions. But it's more than that. The whole point of adopting this particular translator is the proposition that the theory that the analytics underlying that translator are invariant to changes in the policy environment. The translator itself is meant to be a fixed thing. that doesn't change as your economic context alters. And that's an incredibly important thing because it ensures that the approach is capable of generating behavioral responses to changes in the economic environment. So that's the motivation for plugging this thing in. And importantly, this thing, once plugged in, implies a numerical burden that can only be solved in context of existing computing technology by implementing significant stylizations to the model structure. So we seem to be at a little bit of an impasse concerning that first question that I noted on this preceding slide here. So what about the second question? What practical uses can the existing version of the model be put to? Well, here it's crucially important to bear in mind that although the model is impractical for using as a tool for forecasting the future state of the economy, it is explicitly designed to be used to forecast the effects of policy counterfactuals in controlled economic contexts. To do that, you simulate a population under the status quo policy environment, and then you generate a whole new population under exactly the same assumptions, except for the policy counterfactual that you're interested in. You then take differences between the policy counterfactual and the status quo to obtain a measure of the effects of the policy counterfactual looking forward. Now, the fundamental reason that, well, there are two key things to take into consideration which support this idea that the model is an appropriate tool for forecasting the effects of policy counterfactuals. The first is that, as I mentioned a number of slides ago, the characteristics that are embedded within the model, that are represented within the model, have been carefully selected to represent those that we believe are most important in determining responses to changes in government policy. So the model effectively includes the kind of characteristics that are likely to be important determinants of exactly the kind of effects that the model is designed to explore. Moving beyond that, there's this idea that although the model admittedly, the stylizations that are embedded in there admittedly emit a vast array of characteristics that describe the complexity of the actual economic environment. By taking differences between the policy counterfactual and the status quo, the idea is that the effects of this vast array of alternative considerations sort of difference out in your analysis. It's like a controlled differences statistical analysis. Now, moving beyond that, best practice sort of forecasting methods don't just project a single point estimate. They project a point estimate, reducing the tax rate by 3 percentage points will increase labor supply by 1 percentage point. That's a point estimate. But also they provide a degree of uncertainty or a band of uncertainty around that point estimate. And this kind of modeling approach that we're describing here is capable of doing that to the extent that uncertainty is explicitly built into the model. And you'll recall from a number of slides ago that the vast majority of characteristics that are explicitly represented within the model can be simulated in a way that takes into consideration the uncertainty associated with their intertemporal evolution. So it's to my mind, a highly evolved tool for forecasting the effects of policy counterfactuals in controlled economic contexts. It's important to note, however, that this is a dynamic microsimulation model, and there are piles of dynamic microsimulation models out there. What makes SIDD special is this incorporation of savings and employment decisions based on the life cycle framework. Very few models exist which include anywhere near the degree of complexity or the richness of individual characteristics in conjunction with a structurally simulated savings and employment decisions that take into account the uncertainties that people face. And it's this really that really focuses the model on specific topics of interest. And as this slide says here, the model is this approach makes the model ideal for exploring the implications of policy counterfactuals where behavior responses, particularly in relation to employment and savings decisions, are considered important. Now, this will obviously be the case wherever policy is explicitly designed to influence behavior. It also, however, becomes increasingly important as the time horizon is lengthened. To understand the second point, note that let's say you have a policy experiment that you're interested in. And let's say that the policy experiment that you're interested in isn't designed explicitly to influence behavior at all, but it does, in any case, influence both savings and employment by a little bit. Now, the implications of that little bit of variation may be reasonably ignored when the time horizon is really quite short. So, if you were thinking of anywhere up to, let's say, 5 years into the future. But let's say you were looking further into the future. Let's say you were looking 20 years into the future. What happens then? Well, you have small employment and savings decisions in the first and the second and the third year, and so on. Note that as these decisions are taken, they influence other characteristics of they can have potential implications for other characteristics of the household. Things like increased employment each year may lead to a learning by doing effect in the model, which will influence wages going forward or wage potential going forward. Similarly, changes in savings decisions in the near term can have very profound implications for accumulated wealth into the longer term. And what that means is that the characteristics of the individuals might alter very significantly into a 20-year time horizon. And when those characteristics alter quite significantly, not only do you need to worry about the bearing that the actual policy reform that you've looked at has on behavior, but you also have to take into consideration the bearing that the policy reform has on characteristics into the future and how those characteristics then feed through to decisions into the future. And you can see that this can actually be really quite an important consideration as the time horizon is lengthened. Now, these considerations have motivated our focus in most of our past work to look at pensions and pensions policy. And I provide a few references here, 2 papers which explore the UK pensions environment and which are available on this website via the research tab. I should also note that this the time horizon nature of this model was an important consideration in the model's adoption by the Joseph Rowntree Foundation for pricing and quantifying the effects of the reforms that they advocate in their 2016 anti-poverty strategy that was published just last year. So the model is ideal for exploring the implications of policy counterfactuals where behavioral responses are considered important. It's also a useful tool for considering the empirical support for alternative behavioral assumptions. You'll recall that I mentioned that the core of this model really is this life cycle framework, a translation between incentives and decisions. Well, because the model embodies a realistic description of the economic environment. It is a useful tool for considering alternative assumptions concerning the life cycle framework in translating incentives into decisions. And I provide a couple of references to our past work in that respect here. So I hope that that this tutorial has given you some clear idea about what it is we have the model is designed to do, which is available from this website. Any questions or comments are obviously very welcome. Many thanks.